This is the third block of Topic 17. In this lesson, we're going to be able to look at properties of parallelograms. So, in our opening exercise, it says Mr. Vasquez wants his shed to have an 8-foot by 12-foot rectangular foundation. To lay out the perimeter of the shed, he is using a string and stakes. He starts by creating a 40-foot loop, that's 8 plus 12 plus 8 plus 12, and then he stakes 4 corners, making sure the width of the foundation is 8 feet and the length is 12 feet. So if the quadrilateral has one pair of opposite sides with a length of 8 feet and the other pair of opposite sides have a length of 12 feet, does that necessarily have to be a rectangle? Is there a way that he can be sure that he has staked out a rectangle? So let's look at our animation here. So I'm going to move this so I can, let's speed it up. So here is Mr. Vasquez staking out his shed with his stakes and string. Remember, he has 40 feet of string. So do we know that this is a rectangle? He's pretty satisfied that he has created one. But notice I can distort this figure and keep the opposite side still 8 feet and 12 feet. Is it still staying a rectangle as I distort it this way or the other way? Would this be a rectangle? Definitely not, right? So he has to have some way of verifying that the angles he created are indeed 90 degrees. And so what Mr. Vasquez definitely made is called a parallelogram. So even if I distort this figure, the opposite sides are parallel to each other, and so that is called a parallelogram. We'll learn later this topic how he can make sure that it's a rectangle. But for now, he can only be satisfied with the fact that he has made a parallelogram. So by definition, a parallelogram is a quadrilateral with 2 pairs of parallel sides. So I'm trying to get this all in the same screen for you so you can see. Well, I guess that didn't work. But anyway, you can see it on your notes. Number 1, a parallelogram is a quadrilateral, so it has to have 4 sides with 2 pairs of parallel sides. So both pair of opposite sides are parallel. So here's a parallelogram with its diagonals drawn. Earlier in this course, we investigated the symmetry of a parallelogram. And let's look at what type of symmetry a parallelogram has. So in this animation, we can see that we can take point E where the diagonals intersect, and we can rotate the parallelogram and match it up with itself. And so I've always heard this called as rotational symmetry. Agile Mind calls it point symmetry. But it just means you could put your pencil lead on point E, rotate this figure, and match it back up to itself after a 180-degree rotation, which shows us that side AB is congruent to side CD, because remember, rotations are rigid motions, so they preserve distance and angle measure. And so when we rotated 180 degrees, side AB is going to match up with CD. Side AD will match up with side BC, so those are also congruent to each other. We also know angle A, this whole angle, is going to rotate and match up to angle C, so those are congruent angles. And likewise, angle B and angle D would be congruent as well. So we can use the rotation to prove that quadrilateral ABCD is indeed a parallelogram. So look at question 2 in your notes. It says, what do you think is true about the sides, the angles, and the diagonals of a parallelogram? So we're going to look at this animation to help us see that right here. Yep. Okay, so I'm going to drag the dot to show why am I doing this. First, move the green dot to the center of rotation. I don't know what I'm supposed to be doing here. Okay, so I'm going to move this first green dot to choose our center of rotation. So I'm going to try to put it here at the midpoint of that side AC. And then we're going to rotate this triangle and try to create a parallelogram. So voila, right there. Looks like I created a parallelogram. It looks like this side would be parallel to this side and this one to this one. So remember, when I did that 180-degree rotation, I know for sure this angle B is congruent to this one because that rotation did not change that angle measure. I also know this angle right here, BAC, would be congruent to this one because that's what it rotated to create. And this angle, BCA, is congruent to this one. So remember, those are alternate interior angles, and alternate interior angles are only congruent if the lines are parallel. So that's how I can be sure that it is a parallelogram. So we're going to mark some things that would be true on this parallelogram. So you can look at number 2. The first one says the opposite sides of a parallelogram are what? Well, I can mark these opposite sides as being congruent because remember, I rotated this side 180 degrees and it became this side right here. And likewise, this side rotated to make this one. So these opposite sides are also congruent. So that's the first property that you should have marked. The opposite sides of a parallelogram are congruent. Now remember, we already said the opposite sides are parallel, but that was by definition. So it's really important that you understand that's the only property we get from the definition. These properties are not based on the definition. These are theorems that we can prove, and when we use them in a proof, we don't have a name for them, so we have to state them out in words. So we would have to state out in words, opposite sides of a parallelogram are congruent. The next thing we can mark is about the opposite angles. So remember, this angle B rotated and became this angle here. So those angles are congruent to each other. This whole angle right here would be congruent to this whole angle over here. Okay, now we don't know this part of that angle, this one right here, is congruent to this part right here. So the diagonal's not an angle bisector, so be careful with that. But we're saying this whole angle is congruent to this whole angle. So that's the third property, one from definition, one from this theorem. The third property is the opposite angles of a parallelogram are also congruent. Now, the next one says consecutive. So it's really important that we understand the difference between opposite and consecutive. So consecutive angles are ones that are in a row or next to each other. If you talk about it rained 3 consecutive days, you're talking about 3 days in a row. So if we look at our angles here, this angle B and this whole angle C, those would be consecutive angles. And so what do we know to be true about those? Well, remember, these sides right here are parallel, right? Which makes this line right here a transversal. So these angles we have already learned about. They are called consecutive interior angles, and they must have what relationship? Please don't say congruent. This one's obtuse and this one's acute, so they're obviously not congruent. The relationship, remember, is that they are supplementary. The consecutive angles of a parallelogram are supplementary. And then the final one is about the diagonals of a parallelogram. This doesn't really help show us on the animation about the diagonals, but if I draw the other diagonal connecting B to this side, that's a lovely line right here. What we know to be true about the diagonals is that they bisect each other. So what that means is this diagonal AC separates this diagonal into 2 congruent parts. And likewise, this short diagonal divides this long diagonal into 2 congruent parts. Notice I use a different number of tick marks because I'm not saying all 4 of those parts are congruent to each other. Just these 2 parts are congruent and these 2 parts are congruent. So that's our 5th and final property of parallelograms. The diagonals of a parallelogram bisect each other. So both of them are a bisector of the other one. So there are 5 properties about parallelograms that you'll need to memorize. One of them by definition, the opposite sides are parallel, and 4 other theorems. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. All right, so let's look at the first, or actually it's our 4th one. So this conjecture at this point, because we haven't proven it, is the consecutive angles of a parallelogram are supplementary. So we already talked about why this is so. What key properties of parallelograms did we use to justify this? And that's the fact that these sides were parallel. Line AD is a transversal. And so these angles formed are consecutive interior angles. And we have already proven that consecutive interior angles of parallel lines are supplementary. So that is the key property that we used. What does it mean for two angles to be supplementary? Remember, this means they add to 180 degrees. And so our last question says, suppose that angle A is 100 degrees. So if this one is 100 degrees, what does that mean angle ADC, this angle right here, would be? Well, if they're supplementary, we know we just subtract that 100 from 180. And so it has to be 80 degrees. All right, so what I want you to do is go ahead and try to prove number 4 on your own, and then watch the next video and see how you did. Now let's look at what we're trying to prove in this one. We're given that we have a parallelogram. We're trying to prove that the opposite sides are congruent. AB is congruent to DC and AD is congruent to BC. And we're also trying to prove that these opposite angles are congruent. BCD is congruent to DAB. You have answer choices here to fill in these blanks. So see if you can do that on your own and then check it with the next video.